This is the screencast for section 2.3, example 4. We are going to actually learn how to describe a function's end behavior. So first of all, I'm looking at this chart, which you can find on page 204 in your textbook. This chart, the middle of each of these graphs is dashed. Now what that means is the middle will change. We are describing the end behaviors. The middle is going to do a whole bunch of funky stuff depending on what your graph looks like. The end behaviors, though, are going to be the same for different polynomial types, and we're going to explore what that means. So first of all, let's learn how to read this chart. This first graph here up at the top left, this bottom little lim f of x, what that says is the limit of f of x. So the limit of the y values, where the y values go as x approaches negative infinity. Well, as x is approaching negative infinity, that's negative infinity on the x-axis is to the left. So as this function is going left, it is also going down. It's going down to the left, and that's where the y values are going. The f of x values, their limit is negative infinity, which is down. So to describe a function's end behavior, you first need to think to yourself, is this going left or right? So that will determine what is x doing. Then think, is it going up or down? Which will determine what y is doing, or the f of x values are doing. This side is going down to the left, so x is going to negative infinity, which is left on the x-axis, and down to negative infinity, which is down on the y-axis, or negative infinity on the y-axis. This top piece is going up to the right, so therefore the right part of it is where x is going, because the x-axis goes left and right. Right values on the x-axis are positive infinity, so that's why the limit as x approaches positive infinity, as we go to the right, of the y values, f of x, is positive infinity because the function is going up on the y-axis. Now this description over here would describe the opposite end behaviors. The limit of f of x as x approaches negative infinity, so as we're going to the left on the x-axis, the y values are going up to positive infinity, up to the left. Down here, the limit as x approaches positive infinity, so the right on the x-axis, the y values, f of x, approach negative infinity, so that would be down on the y-axis. Now if you notice, n is odd. These two behaviors happen with odd degree polynomials, which means down here, these will happen when n is even. So even degree polynomials. That does not mean they're polynomials. I can't spell and talk at the same time. That does not mean that their symmetry is even or odd. It means their degree is even or odd. So an odd degree polynomial will have one end behavior going down to the left and one end behavior going up to the right, or vice versa. One end behavior going up to the left and the other end behavior going down to the right. Even degree polynomials like y equals x squared, x to the fourth, x to the sixth, or any version of those polynomials, both end behaviors are going be going the same way. They have the same end behaviors. These have opposite end behaviors. Now, how do you know whether both end behaviors of an even polynomial are face up or both end behaviors of an even polynomial are face down? That is determined by this guy. The leading coefficient is positive. You're going to end up with one of these two. Leading coefficient positive. These two are when the leading coefficient is negative. So there's a lot to think about. There's actually three things to think about here. First of all, your polynomial, is it an odd polynomial or an even polynomial? Because that will determine whether it has the same end behaviors or opposite end behaviors. Is actually just two things to think about. Well, that makes life easier, doesn't it? And then the other question is the leading coefficient positive or negative? Because if the leading coefficient is positive, Your odd degree polynomials will have this result. Your even degrees will have this result. Let's look at some examples. I know this chart is super confusing. Let's look at some examples. So example 4, applying polynomial theory. Graph the polynomial in a window showing its extrema and zeros and its end behavior. So we just have to show those things. We don't have to actually find them. Describe the end behavior using limits. So first of all, I'm going to challenge myself right off the bat. Oh, Miss Larson, you overachiever. I know. This is an odd degree polynomial. Odd degree, degree 3 specifically. And its leading coefficient is positive. So going back up to my chart, or even thinking about my basic function y equals x cubed, basic function y equals x cubed has a graph that looks like this. The graph of my function f of x in part A will have the same exact end behaviors as that. The ends will act the same, similar to how you saw that happen in example 3. So let's look at my limits. This one goes down to the left. So I'm going to say the limit of f of x as x approaches, okay, so x is left or right. This end here is going to the left. So I'm going to say negative infinity on the x-axis. The y values, so that's going down, not up. So that the y values are going to go to negative infinity. That's one of my end behaviors right there. The other end behavior, the limit of f of x as x approaches, okay, so now the other end, this end of the function, this end goes to the right, so on the x-axis that's positive infinity, and it goes up, so on the y values that's also positive infinity. So the other end of this function is the limit as x approaches infinity of f of x equals infinity. My challenge here was to create those end behaviors before I graph. So now I'm going to graph and double check that I'm right. So now I've graphed this ahead of time and I found my window. I changed my y min and y max to negative 30 and 30 respectively. But I can see that the end behaviors, the middle acts differently than the basic y equals x cubed graph that I used for a frame of reference, but the ends act the same. My one end goes down to the left, my other end goes up to the right, so my ends behave the same way. I have the same end behaviors. Now I look back at my chart on the previous page. This was an odd degree with a positive leading coefficient, and there are my ends, down to the left, up to the right. Part B, I'm going to challenge myself yet again. All right, so first of all, this is an even degree, specifically degree 4, polynomial, and the leading coefficient is positive. So this graph is going to have the same end behaviors as my basic function y equals x squared. And I know what that looks like from section 1.3. It's just a basic parabola. So the middle of this graph is going to be very different, but the ends are going to behave the same. This first end on the left, so the limit of f of x as x approaches, so on the x-axis we are going to the left. The left of the x-axis are the negative infinity values. The f of x values, the y values are going up. This end is going left and up, so the up on the y-axis are the positive infinity values. So the limit of f of x as x approaches negative infinity is positive infinity. The other end, this guy over here, the limit of f of x as x approaches, let's see, so on the x-axis we're going to the right, so those values out here are positive infinity to the right. F of x goes up to positive infinity, and up on the y-axis, the f of x axis, is positive infinity. So there's my other end. Now let's graph and make sure. So I use the window, I just changed my y min and y max to negative 50 to positive 50, and I can see that the ends do behave as I've described them, just as a parabola's ends would behave. The one end goes up to the left, the other end goes up to the right. And again, looking back at the previous page, I have an even degree polynomial with a positive leading coefficient. So that lines up to this bottom left graph here, and that was where my end behaviors went. And I did describe them correctly using those limits. Also, thinking back to example 2 of this section, notice what happens here. A third degree polynomial has 2 extrema, so 1 less extrema, and 3 zeros, the degrees worth of zeros. Then in part B, I have a degree 4. I have 4 zeros and only 3 extrema, so 1 less extrema than the degree. The now try problem number 19 asks us to graph the function in a viewing window that shows all of its extrema and x-intercepts. Describe the end behavior using limits. So again, I'm going to challenge myself. I am going to predict what those end behaviors will be without even looking at the graph, because if I only rely on what the graph is telling me, as you will find out in later examples this section, that could lead you very, very, very wrong. So first of all, this is an odd degree polynomial, specifically degree 3. This one has a negative leading coefficient. So y equals x cubed is my basic odd degree polynomial that I know very well. But this one isn't using y equals x cubed. It's using y equals negative x cubed, which means I'm going to have a vertical flip over the x-axis. So now my left end behavior is going to go up, my right end behavior is going to go down. I can describe that using limits. So this first end behavior here is going to get described as the limit of f of x as x approaches. Okay, this one's going on the x-axis to the left, so that's negative infinity. The y values are going up to positive infinity on the y-axis. So that's one of the end behaviors. The other end behavior down here is the limit of f of x as x approaches. This is going down to the right. So on the x-axis we are going to the right to positive infinity. On the y-axis we are going down to negative infinity. So now all I have to do is graph and make sure I was right. So I graphed the polynomial, found a new window. My window here, I just changed my y min to negative 100 and my y max to positive 150. And I can see that my left end behavior does go up and my right end behavior does go down. So I accurately predicted my end behaviors. Then if I check those on my chart here, I have a odd degree polynomial with a negative leading coefficient. So odd degree polynomial, negative leading coefficient. Yep, the left one should go up and the right one should go down, where I have described my limits correctly. The limit of f of x as x approaches negative infinity is positive infinity, and the limit of f of x as x approaches positive infinity equals negative infinity.